Okay, so another example that's not one-to-one as per your requests. Let's see, this is 25 grams. So this is my starting quantity. This is what I'm actually putting into my reaction. It's going to decompose and produce 9.80 grams of oxygen. Why is always oxygen? We want to know what the percent yield is. So both of these are physical quantities. This is what I'm actually getting out, and this is what is going in. So the in quantity, this 25.0 grams, is what is going to give me my theoretical yield. My actual is what I get when I put my oxygen on a scale. It's okay. It works. I lost my cheat sheet. Molar masses. There we go. Go back. Okay. So let's do this. So I'm starting with my 25 grams, 25.0 grams. And I need that to be in moles so I can use my stoichiometry. So here we go. Molar mass of KCl3. Yes, there are 122.55 grams of KClO3 per every 1 mole of KClO3. And notice this time I went ahead and gave the balanced equation. That's the worst straight line ever. That's okay. So let's see. I have grams of KClO3 canceling with grams of KClO3. I'm in moles. So now I can use my stoichiometry, my mole-to-mole ratio, to get to my oxygen. So what it is, my mole-to-mole ratio, let's see, the thing I want, I'm going to put on top 3 moles of O2 divided by 2 moles of KClO3. Cool. Now what cancels out? My mole KClO3 cancels with mole KCl3. And just the reminder, harsh reminder, they only cancel with the unit of themselves. A mole of O2 does not cancel with a mole of hydrogen. So it's got to be a mole of something over a mole of something. That's why you keep hearing from me, your units are grams of what, moles of what. You've got to have those pieces together. So now, let's see, we are in moles of oxygen. I now want to know what is the mass of oxygen I could make if I can react all 25 grams. So let's see. My molar mass, I need 1 mole of oxygen has 32, yep, straight 32. 32.00 grams of oxygen. See, cancels. My mole of O2 cancels with mole of O2. So now what I'm going to put in my calculator, 25 times 3 times 32, and then divide that by 122.5 times 2. So 25 times 3 times 32 divided by parentheses 122.55 times 2. And I get really high number. So we're going to double check it. 9.79 grams. Let's say excess. Let me just confirm my notes. Yep. Okay, so that was intentional. Because let's see, though I disagree, it's almost 100%. So percent yield is actual divided by theoretical times 100. So that's going to give us an actual of 9.80. Yeah, it is going to be a little bit more. Grams of oxygen divided by 9.79 grams of oxygen. oxygen. That is definitely going to be greater than 100 times 100. So, yes, right around be 100.1. What are my sig figs? I have 3 sig figs here, 3 here, 1, 2. Whoop. That would be 4. So let's write that correctly. 1.00 times, that feels weird, doesn't it? 10 to the 2%. I know, just the other movement. So, realistic? Could I get that much? It's decomposing some leaves. I would definitely double check my numbers if I got something like that. I would be less inclined to believe it. And at the pace that my videos are uploading, I'm going to go ahead and do, where'd it go? This is going to be very similar to the other example we did in class. So this is a reaction with sodium and chlorine to produce sodium chloride. This one, I want you to stop for a second and see if the information. See if you can do the balanced equation on your own, and then come back. Okay, so I am going to react sodium metal, chlorine, to go to NaCl. So what I always say is if I have 2 on one side and 1 on the other, let's just start there. I have 2 chlorine here and 1 chlorine here, so I'm just going to start with throwing a 2 there. And then I'm going to come back over here. Let's see. So now I have the correct number of chlorines. I have 2 sodium on my product side and 1 on my reactant. So I'm just going to balance it like that. And I'm done. All right. So now what's the question asking? It says, this is saying we know what the percent yield is. That's the 88%. And the theoretical yield is 25 grams. So this question is then saying, what is the actual? Well, that's enough. There's not a lot of steps, but we can still do it. So remember, this is just actual. Oops. Yep. Actual. My brain just suddenly stopped. Divided by theoretical times 100 is percent yield. So I can use that as an equation, like to solve for unknown pieces. So what do I have? This is my percent yield. So I have 1 piece of the 3. And then I'll have theoretical yield. It was 25. This time we want actual. So in class we were solving for theoretical. We weren't solving for actual. So this time, let's see. I want X actual divided by my theoretical is that 25.0 grams. Grams of NaCl. Let's see, times 100 equals 88.0%. So, first step, this one I kind of did in my head, and I apologize, I probably shouldn't have done that. So divide both sides by 100, and I get X over 25.0 grams in NaCl equals 0.88. Oh. So now I just need to get X all by its lonesome. So I can't do anything with it. I don't have an answer until it says X equals, Y equals, whatever variable. It's just got to be all by itself. It's on the bottom. I don't want to subtract it because I would still be stuck with it on the bottom. So I need to make it go away. It's multiplied or divided by the variable of interest. So I need to do the opposite action so I can get that quantity to equal 1. 35.0. So if in doubt, grams NaCl, sorry, should have made room. If in doubt, look, my units, well, the whole shebang cancels here. Whatever I do to one side, I must do to the other. So I'll go and do that. Parentheses. So times 25.0 grams NaCl. So notice I'm going to get the mass of NaCl. So my calculator is trying to not survive the rest of this year. It's very sad. Times 25. 22.0 grams NaCl. That is going to be my actual. There you go. So now we can go all sorts of fun ways with this, and this is going to be a nice lead in to our limiting reactants or reagents or whatever you want to say it. And I think this will be enough for now. So Monday, this is what we'll pick up from.